192.168, or we could simply cat it. Let's cat the contents just to save time, as it's a simple script. It's just a 3-liner. Then on the remote system, we'll nano load averages dot shell, paste the items, and then test it by change modding +x load averages dot shell, and then trying to execute it, where we see that it has run successfully, and a cat of load averages dot text looks like what we want. So again, it seems to be working. Let's cat the contents of load averages dot shell to see why it stripped the initial field. Let's uptime, and because the fields are displayed differently, it returned it slightly differently. So in this case, it's specifying the fields as the 1st, 2nd, 3rd, 4th, 5th. So we really need to get 6th, 7th, 8th, 9th, and 10th. So different systems causing the output to be displayed differently. Let's nano again. That's going to be 5 through 9. But before we modify it, let's just dump the output to the screen to be sure that it works. And notice awk simply discarded the fields that were not available. So we'll strip 10 through 12. Again, differences across systems. And that looks more like it, although it got the users, which we didn't want, so perhaps it's fields 6, 7, 8, and 9. That's more like it. So we'll update our script with the new set of fields, and then move on. Again, always test your scripts to be sure that they work before committing them to the process, into the cron environment. And now when we execute load averages.shell and cat the contents of load averages.text, it looks better. That's more like it. So for this user, we'll cron tab E and then place a schedule. And again, you see it's using VI, so let's export editor, setting it equal to nano, and then cron tab E again. So we want it to run every minute of every hour, of every day of the month, of every day of the week, the following command. And on the remote system, let's just be sure we have the full path. It's home1, student1, load averages.shell. Let's be sure that that's the name of the script, and it is load underscore averages.shell. That's all we need to do. We'll save this, and now the entry gets written in var spool cron. To confirm it, cron tab as the user list -L, and you'll see the entry and its schedule. So we've created the entry, and just note cron tab -L enumerates per user cron entries. In our case, there's only one entry. So when cron wakes up at the next minute, this process will execute. And we can watch it based on the current time to see whether or not it will run. We'll cat the contents of load averages.text, where it currently has only one load average line, and it will run momentarily. Now when cron wakes up, again, what it's going to do on the remote system, let's just show you, is read, in addition to other things, var spool cron, where it'll find an entry for student1. There's the entry. A file against student1 tells you it's ASCII text, and if you cat its contents, it basically has the entry that we defined, instructing it to execute the load underscore averages.shell script. Now that's per user, but system-wide, would be affected by updating etc cron tab. So it's stored in etc cron tab. Update this file, and you'll be off to running things from the system. So create a cron entry in etc cron tab to do something, such as pinging a remote host and keeping track of it. Again, we have to determine what we want to do, and we could even do it on the local system to avoid confusion. So supposing we wanted to ping our default gateway to make sure it's up, sending 3 packets every minute. We'll ping -C3 192.168.75.1, and it returns the following output that we'd like to place into a file. So as root, let's define the script in our home directory. We'll nano and call it pingtest.shell, reference the location to the bash shell, and then indicate our command as ping 192.168.75.1, sending the output into file name. And that'll be located in root ping_test.text using append redirection. We'll test it first, and then, after flagging it executable, of course, and let's just take a look. We referenced the wrong variable. It should be file name 1. And let's try that again. And that looks like it's working. Let's cat the pingtest.txt file, and there you have the output that's of interest. So now we can place this into the global file. Let's just copy the name, then nano etc cron tab, and again we'll have the entry run every minute. Big difference in the global file is that you indicate that the user with which cron should execute the process. In this case, the user is root, followed by the full path to the process, which is root pingtest_shell. Again, in user-based cron tabs, because the files are named accordingly for the user, there is no need to specify the username. But in system-wide cron tabs, you need to be explicit about who the process should execute as. Let's save the changes, and every minute the process will run. Cron is, again, not very complicated. Once you understand the scheduling, then it's left up to you to define a script, a runnable script, such as Perl, PHP, Python, or Bash shell, and then program it into the cron scheduler, either on a system-wide or per-user basis. Now let's check on the progress of student 1's shell script. We'll cat the contents of load averages underscore text, and there you see multiple entries telling us that it's running as expected. And if we check for an update on the ping test, we should see that it has written additional items to it. Now you can interrogate a remote system's or remote user's entry if you'd like, and we catted the wrong one, it's pingtest.text. Cron entries using cron tab. Let's just note that cron tab-l followed by username does what we mentioned above, which is to enumerate the specific user's entry, but above is the form that you'd use if you're logged in as the non-privileged user. If you're logged in as root, execute it this way. So if you're root on a system, let's say on Linux CBT Serve 4, and you'd like to see student 1's cron entries, short of actually navigating into var spool cron, cron tab list student 1 will do the trick. And this will tell you student 1's entries in the cron table. And there we see the entry. That's list-u username. So as root, we can enumerate other users' cron tab entries. However, as a non-privileged user, you're unable to list root or other users' cron tab entries. So now cron will wake up again. It's always running. It's a daemon. But it'll wake up every minute in search of changes to any of the cron files. It looks for changes in the modification time of those cron entries. It also searches for new entries in var spool cron to determine whether or not they're to be processed and executed. And if so, again, it launches them, does what it's supposed to, and it will also send a mail to the user indicating, in particular the root user, indicating whether or not the process has executed. Cron also maintains a log file beneath var log, known as cron. You can tail the contents of this file to determine if cron's doing what we expect it to do. Both Red Hat systems maintain the cron entries, and all Linux systems support it, but not all Linux systems enable it by default. The key to understanding cron, just to recap, is its scheduling capabilities. The fact that you can indicate items to run every minute, hour, day of the month, day of the week, and the fact that you can use asterisk and multiple steppings, such as 0, 2, 4 to run things at the 0th minute, 2nd minute, and 4th minute. Using commas as well as dashes like you see here, you can indicate a range or multiple items for the schedule. Apart from that, it's really straightforward. There are entries in there to help you get started with running your processes. But understanding and using cron begins with having to have something automatically run without your intervention. So once you have a process that works without cron, outside of the cron facility, then you may either set it up on a per user basis if the user has enough privileges, or even per user free root, or even system-wide in the etc cron tab file. And one other note, you should try and schedule your cron entries to run when other cron entries aren't running, so that they don't end up competing for and monopolizing the system's resources.